Poincaré was also interested in philosophy. In fact, he was one of the founders of a new journal that came out in the late 19th century that was designed to create a philosophy around science, where he and other polytechniciens at the time would think about the fundamental questions of philosophy through the lens of what was being understood in science. So they'd ask, for instance, what did time mean if you didn't have a measure? You were always speaking of something in motion. If you said, for instance, that a pendulum swung at a certain rate, did that set the standard of time and then you use that to measure the turning of the Earth? Or did you use the turning of the Earth and then talk about the motion of the pendulum relative to that? You always had to make choices, and Poincaré was deeply committed to that idea. In January of 1898, he wrote an article on the philosophy of simultaneity. What do we mean by this idea? What do we mean by measuring time? He said if two longitude-finding telegraphers want to coordinate clocks, what do? Well, one sends a signal to the other, taking into account the time of signaling. Time of signaling takes a second from one place to another. It'd have to be a pretty far place, but it takes a second. Then if you send it at 12, then you set it on receipt at 12 plus 1 second. Now, this could be thought of as a kind of brain in a vat, imaginary thought experiment. But it wasn't. Poincaré was reporting on what he saw all the time by his time signaling telegraphers who were finding longitude. That's what they did. The Paris Observatory would send a signal out, bounce it off Recife, say, and get it back, figure out how long that took, divide by 2, and then from that, know how long it took to get from Paris to Recife in Brazil. So if you set the clock 12, if the clock said 12 in Paris, then Recife would set it to 12 plus half that round trip time. This was important because what had been just an ordinary piece of everyday map making, longitude finding, became Poincaré's definition of what simultaneity really was. You couldn't refer to the sensorium of God or metaphysics or the equable flow of time. He had a procedure, and it was the procedure that determined what was simultaneous. So now we could ask, do we think that this idea of the exchange of electrical signals being used to set simultaneity of two distant clocks, is it truly an idea of philosophy, or is it truly an idea of engineering? Well, in 1898, it was both. It was at the intersection of two different paths. It had a role to play in the development of this new philosophy of science, and it had a role to play in the establishment of longitude for all of the great powers, for Britain, for the United States, and for France. But Poincaré believed that it had nothing to offer physics itself. He thought the corrections, because of this, taking into account signaling time, would never be competitive with the much larger errors that were introduced in synchronizing clocks, say by the error introduced by the telegraph operator in his reaction time to hearing a beep and hitting the key. But that changed. On December 10th, 1900, Poincaré was asked to speak at a conference in honor of Lorentz. And when he did, he realized that an idea of Lorentz could be very important. Lorentz, you remember, said that objects had to contract a little as they moved into the ether. Poincaré thought that was fine. But in addition, Lorentz said maybe we need to change this variable t for time that occurs in our equation. And if we modify it just a little bit, then it'll make the equations look mostly the same in different moving frames of reference. Well, Poincaré hated that idea. He thought it was ad hoc, it was arbitrary, no reason to do it. But then as he was preparing this talk for the 10th of December 1900, he realized that there might be something to what Lorentz was saying. That in fact, if you pictured two of Poincaré's telegrapher longitude finders, as they move through the ether, the first one of them, say, sending a light signal to the second, as they move through the ether, that light would have to push against the apparent wind of the ether as you moved through it. Well, Poincaré calculated what that effect should be and realized that he got just the quantity that Lorentz had introduced as a purely mathematical artifact. So now Poincaré said, well, maybe what I have done for defining time at a distance in an ether rest frame could actually be extended to a frame that's moving in the ether, and then we need to introduce this local time of Lorentz. Now we have a triple intersection: the path of map-making and engineering, the path of philosophy, this new philosophy of science, and the path of physics. All three contained this idea that two events were simultaneous if two clocks were coordinated by the exchange of a signal. That was at the core of all three transformations, of what was being used to determine longitude, of what was being used to define the philosophy of simultaneity, and what was being used to redefine time in this centermost area of physics, the electricity and magnetism of things moving in the ether.